Greetings, this is Mark Anderson from Kellogg Community College with part 3 of our binomial expansion formula introduction and explanation. Now, we are going to, in this video, get to 2 examples and then the binomial expansion formula. Having taught this a couple times before, I have found out that actually doing some examples and then going back to actually write the binomial expansion formula tends to work out better, because once you see a few examples in action, you can then kind of like figure out why the formula is the way it is and why it's written the way it is. So what we're going to do is we're going to start off with 2 examples. The first example here, which matches actually one of the results in our first video, where we took just a plus b and raised it to the 4th power. And then we're going to see what happens when a and b aren't actually 1, in this case, or don't have coefficients of 1. Like this case is the coefficient is 1 and this is a negative 2. So we're going to use, from what we learned in the previous video, about ways to find combinations. Now, what we should start with is we should start with this idea that a plus b to the 4th power has a set number of terms. Now, going back to the previous videos or just thinking about just binomial expansion in general, the number of terms will always be 1 more than the power given. And we've seen this with a plus b to the 1st power having 2 terms, a plus b quantity raised to the 2nd power having 3 terms, and a plus b quantity cubed having 4 terms, so the pattern holds true. We're going to write down 5 blanks, and these 5 blanks will represent the 5 terms created by the binomial expansion formula. Now, the first thing we're going to do is we're going to put kind of in the front of these the tall parentheses, and these tall parentheses are combination formulas. These combination formulas are used to help find the coefficients in front of these numbers without having to make a Pascal's triangle. So this is going to start with the power 4 and start with the 0 here. And then these will increase by 1 integer for every step until we get to the final part where it's just 4 over 4. Now there will be 2 other sets of parentheses next to these, and having taught this before, I sometimes called this the mama owl and the 2 baby owls. And these 2 baby owls will be whatever terms are, or whatever, terms are inside of this binomial. So this would be AB, and this would be AB, and this would be AB, AB, and finally AB. The powers, starting with A, begins with 4 and descends all the way till we get to 0. And the B, starting from this left side, starts with 0 and grows until it gets to 4. And then what we'll do is we will process each one of these parentheses and figure out what it makes. Now, for choosing 0, this is a combination of saying if you're going to choose 0 items from a group of 4, how many ways can you do it? Well, the answer is 1. A to the 4th is just written as a to the 4th, and b to the 0 is written as, and that's really supposed to be a 0. I guess I made it worse the more I try to mess with it. That b to the 0 is going to be a 1. Any number or letter or variable or anything raised to the 0 power is 1. So this first term breaks down to a to the 4th. And if you go back to our first video, you would see that that is the case. Now, for choose 1, this is like choosing a 1 object in any order from 4 objects. There's 4 ways to do that. And this would be a cubed, and b to the 1st power is a way of saying b. So this is 4a cubed b. And like in previous examples, you now see that the a power is descending, the b power is ascending. But these combinations are taking care of the number in front. In this case, choosing from 2 items from 4 in any order, there are 6 ways to do that. And then we have a squared b squared, so this is 6a squared b squared. Choosing from 3 items from 4 in any order, there are 4 ways to do that, with basically 4 left over. And then we have a to the 1st power, which is a, b cubed, which is going to be 4ab cubed. Now, if you're curious about how I'm getting the 4, the 6, and the 4 from this combination notation, I strongly recommend that you watch video number 2. And the video number 2 in this series explained how to type this into the calculator, or without a calculator, how to write it down. So it's incredibly important to know how to process this combination notation to get these these coefficients in front of these variables. And finally, 4 over 4 is just choosing 4 objects from a group of 4, and there's only one way to do that. A to the 0 is also 1, and b to the 4th is just b to the 4th. And here is my 5 terms of an expanded binomial, this a plus b quantity 4. And you can go back to the first video and see where we did that. Now, if we're going to go down here to ax minus 2 to the 3rd power, you'll start off with writing 4 terms. 1, 2, 3, and 4. We're going to now make our mama owls, our big, tall parentheses for our combination notation. 3 over 0, 3 over 1, 3 over 2, and then 3 over 3. Then we're going to have our little baby owls being x's right next to mom. And right next to the x's are going to be negative 2's. So there's our negative 2, there's our negative 2, and there's our negative 2. And now let's be very cognizant of these powers. This is a 3, 2, 1, 0, and then 0, 1, 2, and 3. So choosing from 3 items, none of them, there's only one way that can happen. Or if you're typing this into the calculator, this would be 3 NCR0. And then this x cubed would just be x cubed, and negative 2 to the 0 power is 1. And so my answer for the first term is x cubed. 3 choosing 1, and if I have 3 choosing 1, I'm just choosing one item. There's 3 ways to do that. X squared, and then the negative 2 to the first power is just negative 2. So this makes a negative 6x squared. My next term is going to be 3 choosing 2 items, and there's 3 ways to do that. X to the first power is just x, and then a total of here positive 4. So we have 12x. Then another plus. 3 choosing 3 is 1, x to the 0 power is 1, and negative 2 to the 3rd power is negative 8. So my final term is negative 8. So this is my binomial expanded using the formula that we're about to write. Now let's kind of like look back at the pattern here. It looks like this first set here was a combination formula where we started off with the power, and then we had the number here, and it grew up until it got to this level. It looks like the power here basically matched subtracting these two. 3 minus 0 is 3, 3 minus 1 is 2, 3 minus 2 is 1, and 3 minus 3 is 0. And this power matched this number down here. So let's actually go back up to the top here of this worksheet and try to reconcile what the binomial expansion formula would be. So the first thing we're going to do is we're going to start off with the idea, whoops, hold on, got to get my pen ready, that the numerator, well, the first number here is n. This is the power that kind of sets off the number here at the top, and we'll start that with 0. Then we're going to have our a, our first term here, to the nth power. And we're on to the second term. We're now going to have n, and we're going to have in the denominator a 1. My a is going to be dropped by a power of 1, and then my b shows up with the power of 1 here. And we're going to keep going. This is n over 2, and that means that my a is going to be n minus 2. And my b is going to be now the second power, and that's going to continue on and on. In the middle of all of this progress, we can see that the pattern getting to our problem where this is n and r. And you can see that in the previous video I've made, part 2, we talk about n and r, and n being the number of items and r being how many we're choosing. Well, the a variable will always be n minus r, so subtracting these two will give you this power here. And then the letter b will always be r. That's why there was no letter b over here, because b to the 0 power is 1. But as soon as we increase this by 1, a b shows up to the first power, and so on and so forth. And the difference between n and r, whoops, didn't mean to make my little scratch there, is going to give me this n minus r here. And it keeps going and going and going until you try to figure out when are you going to stop. Well, you're going to stop when you finally get to this final term where there is n over n, and you can see that in my previous examples it was 3 over 3 or 4 over 4. There will be no more a term left because n minus n is 0, and n minus, basically there's no letter n, and b would then be raised all the way to this bottom number here to the nth power. And this is the binomial expansion formula. So again, I want to go through the previous example that we had down here. This is a to the fourth. I'm doing the example of a plus b raised to the fourth power. But now with this in front, you can maybe take a better look at it here. This is a to the fourth, and then we have 4a cubed b. So you'll notice the a's are descending, the b's are growing, plus 6a squared b squared, so the a's are growing, the a's are descending, the b's are ascending, plus 4ab cubed until you get to the final term here, and that final term here is going to be b to the fourth power. So the coefficients, these 4, 6, 4, that comes from the combination formula here of 4 over 0, 4 over 1, 4 over 2, 4 choose 3, and 4 choose 4. So in our final video that we're going to do here, we're actually going to just do more and more examples. So if you feel like you've got a good handle of this here, you can skip the fourth video. I'm going to do, let me think here, I'm just going to check out my notes. We're going to do 4 more examples in the next video, which should take about 10 minutes or so. So thank you very much for watching. I hope this has helped you learn more about the binomial expansion formula.